All right, so we are now moving on to the third of 5 different types of chemical reactions and predicting products. In this video, we are going to talk about specifically how to predict the products of single replacement reactions. But once again, to review, we're going to always start by using the reaction template to identify the type of reaction, using the reaction template to identify the products, checking the charges of the metals and the nonmetals and crisscrossing them down. For single replacement reactions, we'll talk about the activity series, although not today. For double replacement reactions, we'll talk about solubility rules, although not for today. And then balancing the chemical equations, which will be the last step. So, as you might recall, the single replacement reaction template has 2 versions of it. There is a one that we wrote as B plus AX reacts to form BX and A. And in this case, what we have to remember is that metals replace metals. And I realize that like hydrogen in this case is technically not a metal. It's a nonmetal. But for balancing and predicting products of reactions, we're going to treat hydrogen as a metal. So hydrogen is going to be the thing that's going to be replaced here. So the first thing that we're going to do is we're going to write zinc and chlorine. Going to match those up. And then we're going to write hydrogen by itself. So the first thing we have to do is check the charges of zinc and chlorine. So zinc, according to the periodic table, is a charge of +2. Chlorine, according to the periodic table, is a charge of -1. When we crisscross those charges down, we get Zn1Cl2. And so we're going to rewrite this in our formula to be ZnCl2. The next thing we have to do is we have to check to see if any of the elements, in this case the hydrogen, needs to have 2 after it. So we have to remember that there's Br2, I2, N2, Cl2, H2, O2, and F2. And the H2 is a true thing that needs to have a 2 after it. So we're going to write H2 like that. All right, so now that we've checked our charges, crisscrossed them down, we've checked to see if there's a diatomic element, and we made sure that it had the appropriate symbol behind it, we are now going to go ahead and balance this equation. So we have zinc on the left side, hydrogen on the left side, and chlorine on the left side. And I have 1 and 1 and 1 of each of them. And on the product side, I have 1 zinc, I have 2 chlorines, and I have 2 hydrogens. So going from left to right, the zincs are balanced. So I'm going to leave that alone. Hydrogens are not balanced, so I'm going to put a coefficient of 2 here. And when I do that, that gives me two hydrogens and also 2 chlorines. So now we've balanced this particular reaction. So that's one example. So we're going to do a second example real quick once, which is a little bit different. In this case, we have y plus ax. Oops. Which is going to produce ay and x. And so in this instance, when we have this scenario, what we have to keep track of is what's replacing what. So in this example, we have a nonmetal and nonmetals replace other nonmetals. So when I set this solution up, I'm going to have Na, and I'm going to have F, and then I'm going to have Cl by itself. And so the next thing we have to do is we have to check our charges and crisscross them down. So Na is a +1, F is a -1. When I crisscross the charges down, I get Na1, F1. And so I'm going to leave that alone. The other thing that we have to check, especially when we have individual elements, is if there are any diatomics present. So I have Br2, I2, N2, Cl2, H2, O2, and F2. And it looks like, in this case, I have a Cl2, so I need to have a 2 back here. So now all that's left to do for today anyway is to balance these reactions. So I have an F, and I have an Na, and I have a Cl. So on the left side, I have 2 Fs, 1 Na, 1 Cl. And on the right side, I have 1 Na, 1 F, and 2 Cls. So to make this balance, I am going to add a coefficient of 2 here. And when I do that, that gives me 2 NAs and it gives me 2 CLs. So my NAs my CLs are balanced, my NAs and my Fs are not. I'm going to add a coefficient of 2 here, which will give me 2 Fs and 2 NAs, and then this reaction is balanced. So those are the two of the 3 different types of single replacement reactions. And now we're just going to do one final one, just as a quick practice. I would like it if you took the time to pause the video. And if you paused the video, did it yourself, checked your answer when we're all said and done here, that would be fantastic. So I'm going to give you a second to pause the video and work through this. And we're back. So now in this case here, we have what I see to be a metal. Copper is a metal, and that's going to be my B. And then I have AX over here. So because metals replace metals, which we said before, I'm going to end up with B, X, and A. So in this case, I'm going to simply match up what I have. So I have Cu and NO3, and I have A, which is all by itself, which happens to be aluminum. Now, in this case, you might look on your periodic table and you might notice that Cu is a transition metal, and we actually don't know what the transition metal's charge is based on its location on the periodic table. I'm going to tell you that for the sake of argument for this one, that Cu is a +1. So we do need to go back and check our charges. So Cu is a +1, and nitrate on the back of your periodic table, NO3, is a -1. We crisscross those charges down, we get Cu1, NO3, 1. So I'm going to leave that one as it is. To balance this though, I have a Cu, I have an Al, and I'm going to have, because I have NO3 on both sides, we're going to use the common ion hint, so it's going to be NO3. So I have 1 Cu, 1 Al, and 3 NO3s, and I have 1 Cu, 1 NO3, and 1 Al. To make my NO3s balance, I'm going to add a coefficient of 3 here, which will give me 3 NO3s, but it'll also give me 3 Cus, so I need to go back and put a coefficient of 3 here. Then everybody's happy and everybody's balanced. So that's predicting products for single replacement reactions. Remember, metals replace metals and nonmetals replace nonmetals, and that's one of the first things you have to check when you start doing a reaction like this. Again, if you have any questions, please don't hesitate to ask. Otherwise, good luck with this particular note set.